The new all-purpose ink man has arrived with all your favorite catchphrases like
It's time for game plans!
and capable of doing anything you need.
Hey math lovers, let's go over lesson 8.5, estimating population parameters. What's our learning goal, our learning targets here? Our standards for mathematical content is students use the sample data to make inferences about the population. I'm very fortunate. I get a lot of surveys to get data from me. And I get these emails and they say, what do you do? I'm a teacher. And then they might ask me like, what kind of curriculum do you use? What kind of teaching methods do you use? What type of supplemental material or technologies would you like to see? And what they're trying to do is they're trying to get some data from me. Like, what do I think is helpful for students to learn math? And I get paid to do those surveys. Now, sometimes those boring surveys, if they're not going to pay me, I'm probably not going to take them. That's why, you know, at the end of your receipt, like if you go to McDonald's, Jack in the Box, they always ask you want to take a survey and they're willing to pay you. They're trying to get some sample data to talk about the whole population. All right, how can we meet this standard? I can use sample data to make inferences. About the population parameters. All right, let's go to our warm-up over here. I have four numbers, 8, 10, 14, and 15. Go ahead and press pause. Try this on your own. See if you can do this on your own, and then press play if you want to do it with me. All right, it tells us to write all the possible selections of a sample size 3. So I just need groups of 3, but there's 4 numbers here. So maybe you have like 8, 10, and 14. Or maybe let's skip 10 this time. 8, 14, 15. And then how about 10, 14, 15? So it looked like I used 14 3 times. I have not used 8 3 times, so how about 8, 10, and 15? Okay? So there they are, and then it tells me to find the mean or the average. So all I have to do there is x bar equals, I add up all of the numbers and I divide it by the number in my list. So for example, that would be do that in a different color over here. If I add up all of these numbers, and there's 3 numbers in the list, I divide it by 3. This would give me a mean of 32 divided by 3. So I'm just gonna use the calculator for that. Let me take a screenshot. Picture with my cell phone. There it is. Then I'm going to show you. I use this thing called Graph and Calc 83 over there by my Cooking Fever. And then we're going to press Stat button next to the left arrow. And then I'm going to press Edit. And then you can go up to the list. So this mimics a graphing calculator. So if you have one, or if you need help getting one, the school cannot provide you one, but you can download one like this on my tablet, your phone, or I can tell you other ways to get like used ones. All right, so the first one was 8, enter, 10, enter, and then 14. And then that's in L1, so I'm going to press now Stat, left arrow, Calc, so next to the edit, and then 1 var stats. And remember, your default is just L1 in here. But if we need to, we can. So I'm going to press second, the orange button, and then number 1, because that'll give me L1 in orange. And you don't need to close it. And there I have my average, 10.66666. And just to review your rounding, this is the one that we need. That is the hundredth. So I need to actually look at this number. If this number is 5, 6, 7, 8, or 9, then this number is going to go up. So my answer is going to be 10.67. And let's go ahead and put that in for the rest of my numbers. Stat, edit. You can do the same thing in this list again if you want to. So now I have 8, enter, 14, enter, 15, enter. Now you have to press enter on that third one so that the 3 numbers are inputted, and press stat, calc, one of our stats, and you just press enter. And there at my average is 12.33. 12.33. Now, even when you're doing your calculator commands, I saw in your those who turned in their work last week, you might want to still kind of show a little bit of work. And all the work you need to is actually still in your calculator. Let me show you. Summation x is underneath x bar. It says 37. And that basically means 8 plus 14 is 22. And 22 plus 15 is 37. So you have 37 divided by 3. That is sufficient math work to kind of let us know that you didn't cheat. You at least understand how to find the average. Okay. Do the same thing for this one. 10, 14, 5. I'm going to go a little faster here. You've done this a couple of times. 10, 14, 15. And stat, calc, one bar stats. So summation is 39. The average is 13. And that one doesn't have any decimal places. It's 13.00, but you can just write 13. That's still rounding to the nearest hundredth. So if you really want some zeros, you can add that there. And then this one you can just do on your own. You can put in your calculator, but 18, this one's 33 divided by 3. So this one is 11. Okay, for the set of means you found in exercise 1, find the mean and standard deviation to the nearest hundredth. Okay, so basically what they want us to do, I'm going to use a highlighter because this might make more sense. These numbers, we're going to find the mean of them and then the standard deviation. So now I'm taking the 4 numbers, so if this makes sense, given these numbers, go ahead and find the mean and the standard deviation of these numbers. So let's go ahead and do that. Stat. So the hard part in my calculator here, I can't show you like the clicking and the buttons. So I say it out loud. Edit. Go to the top of your list. Press clear, which is near the down key. Enter. 10.67, 11, 12.33, and 13. Stat, calc, one of our stats, and press enter. There, my average is 11.75, and my standard deviation is 0.95. Oops, this one should have been a sample. Okay, so those are our answers. And then it tells us, get another color here, let's do dark color like purple. What are the mean and standard deviation of the original set? So now they want us to look at For 3, they want us to look at these numbers right here, okay? So if I write those numbers down, 8, 10, 14, and 15. And there is a reason for this warm-up. It's not just, let's just do a bunch of stuff from the past, which is good for us. So we still want a mean and that's a mean population. That symbol there is mu, which we're going to review later. And this symbol, this one should have been an S. But anyways, let's put in those numbers. Stat cal. Oh, see, I have to go through it. Stat edit. Go to the top of the list. Press clear. 11.75. What am I doing? Come on. Wrong numbers, guys. I need to drink another sip of my coffee. Delete. There we go. Okay, my numbers are 8, 10. This is the original numbers from the top of the problem. 14 and 15. Stat, calc, one of our stats. And my numbers are 11.75 and 2.86. So that would be 11.75 and 2.86. I'm going to give you guys an analogy, and this will kind of hopefully make sense because it's like super real statistics. Let's just say this is our school. Let's just say this is the CVA school. This represents all the students in the CVA school. And, you know, there's not just 4 students in CVA. Let's just say there's like, I don't know, 400 students, teachers and staff, and supporting staff. And basically, you know, we can't test everyone for COVID because it would just cost too much and take too much time. Let's just say no one can enter the building. Let's say it's a real school, not a virtual school. And we want to make sure everyone's safe. So we have to test everyone every single day. Well, this would take too long, right? The lines would be long and it would be really expensive. So you can just take small samples. Let's just say we just take every 3 persons, right? And then we get their samples right there in blue, green, red, and black. And this will kind of inform me about some data, right? And if you look at it, if you actually could take the population, if you can test everyone for COVID every single day, maybe our numbers look like this on the second list. So I'm going to call this one the sample, and I'm going to call this one about the whole population, because we actually found the whole population in question number 3. Well, if you notice something, the average was pretty much the same. And let me draw a picture here of our normal curve. This is actually the center, right? That's the center. That's what the 11.75 represents. And if you find something really interesting, the variation, the standard deviation in our sample, because we took so many other smaller samples, was small, but our variation or spread for the whole population was big, okay? This will make sense when we go over to the launch. So let's go over to the launch over here. And I want to talk about some notation. Like we said, it's not always feasible. It's not always a good idea, or maybe it's too expensive for us to always figure out what the population. So the first box over here, we're going to call is the population is a review is all. And when you get numbers from the whole population, that's called the parameter. You're getting parameter. And where did my colors go? And we're focused on the mean. You're not a mean person. Remember, that just means the average. Standard deviation. Standard deviation, which is a measure of spread, and your proportion, which just is a fraction, right? Part over whole. Okay, so the symbol or notation for the parameter for the mean is this symbol. Let me see if I can get in really close. It's like a weird U, so long line, and then you draw your U. Notice how that line does not go all the way down, and it is a Greek letter, and they just call it mu. Mu. I think there's a Pokemon like that. Some of my kids do. Okay, and then for the under parameter for standard deviation, you have this long tail. It's an O, and then you draw a little tail on the top there, and this one's called sigma. Sigma. So if we were taking all the data from the whole school, we are basically taking it's called a parameter. And then the last one, a proportion, is just P. Okay. Let's change it to my purple. Okay, so you're like, we can't take a sample of every single person entering CVA. That would take too long and too expensive every day. Not practical. So we can just take something called a sample. You know, if you've ever been at Costco, a sample is just, you know, taking a sample of what you're packaging, of what you're buying, just a little bit. So I'm going to call this sum, right? Some of the students at CVA would be, or adults and teachers would be tested. So when you take a sample or some of it, the information you're getting for them is called a statistic. A statistic. And remember, we kind of talked about this before. Population, parameter, sample, you get a statistic there, right? Okay. And for statistics, this one we get, you actually see in your calculator, which means your calculator actually is not, it's a tool, but it's not super accurate. So when you only have a sample, this is called a, how do we pronounce this one? This one we call X bar. It's an X, and you just put a bar. My X there just had a little tail. That doesn't matter. Just draw an X and put a bar over it. And then the standard deviation is just it's just an S. Okay, this one's kind of funny. We're having issues at my home site, but a proportion is the same thing with a P, but to show that it's a sample, we put a hat on it. And we actually call this P hat. Not fat, P hat. And so that is our notation. Okay? All right. I'm going to show you guys a visual about all this. I know it's just a bunch of statistical information, but it'll make sense when we talk about candy, because everybody loves candy. So I have some Reese's Pieces here. And this is a Reese's Pieces machine. And you might be wondering, in this Reese's Pieces machine, what percentage of the candy is yellow, red, and orange? Well, in this activity, you have all of the candy in the machine, and we can play kind of like Candy God and determine the probability of orange. So let's just say I set it to be 50%. Remember, a percentage turned into a decimal is 0.5. So I'm telling you, even though what you see in this picture of that half of the candy is orange, okay? And let's just say you get to put in a nickel or quarter in there, and you get to determine how many pieces of candy are coming out and how many kind of like quarters you have. Okay, so let's just do this. And I'm gonna show the proportion of orange, okay? All right, so here goes the machine. You put in a quarter, you got 5 pieces of candy, and you have 2 orange. So if you multiply that, 2 out of 5, that would give you 4 out of 10, and 4 out of 10 you multiply by 10, that would be 40 out of 100, so that gives you 40%, okay? And so what they did is they took this 0.4 and they put it here on our dot plot. Okay, that's kind of gypped, right? We were supposed to get 50% orange, and this one only showed me 40%, so let's do it again. Uh-oh! The next time I put in a quarter, out of 5 pieces of candy, I got
4. So that's 4 out of 5, which is 80%. That's a lot higher than they told me, 50%. So if I keep drawing these, whoa, I love orange Reese's Pieces. So I got 4 out of 5, which is 80% again. There's another dot. And you can keep doing this. This one got me 3 out of 5, which is 60%. Wow, this machine. Wow, we're getting so lucky. We're getting all the orange pieces, which I love. Uh-oh. I'm not happy. This is 2 out of 5. This is lower than what they told me they were going to do. And if I just keep drawing lots and lots of candy, I'm going to shut off the animations now so I can do this a lot faster, right? So every time I'm pressing draw samples, I'm putting in the quarter, I'm getting 5 pieces of candy, it counts it, and it's just graphing it. And you would expect that at point 50, right here in the middle, guys, we would have more of our candies. Does this make sense? Let's try this again. Let's do, let's draw 10 pieces. Let me reset this thing. Okay, let's do 10 pieces of candy. Okay, the first time I got 5 out of 10. This one I got 2 out of 10, which is 20%. This one I got 5 candies, so that's 50%. That's what I expected, right? And keep doing this. Doesn't matter what you set this to be. That one got 4. Whoa, that one got set at 10. That was 70%. I'll shut off the animations so I can go faster, and I can just keep drawing candy, right? And so you might think like, whoa, look at ours. Not just the number, we were getting 3s and you change this to proportions. We're getting 30% when it's supposed to be 50%. So this is skewed, right? This is skewed right. All the data is to the left, and then my tail over here is to the right. There's not much over here to the right. So let's keep drawing. Oh man, this thing is not pulling out my orange candies. What's going on, guys? But as you keep taking more and more, you'll notice something. What do you guys notice? Oh, it caught up. Okay, let's do now 10 samples at a time. What's happening now? As I keep taking more and more, putting more quarters in, getting more candy. Let's go crazy. Let's do 100 now. Wow, those dots they turn into lines now because we're putting so much data in there. It kind of looks now what? It looks approximately normal. So as you increase your sample size, and this should make sense because I'm basically draining. You're like, how much candy's in there? You're basically, when you're drawing it, so much samples, you know, we've taken, here, let's go crazy again. I don't know, get a couple of zeros there. That one just drew like 10,000 quarters or 100,000 quarters. The point is, as you increase the sample size, your data becomes approximately normal. And that would make sense because if you kind of basically are taking all of the candy out, you're like, let me see all the candy in here. This will kind of tell you what's happening. Now it says the positive experience index score is the mean or average of the measures of positive responses. Positive responses is your fill in the blank to questions asked of adults in 140 countries. Higher scores mean or explained by that they have positive emotions, are more pervasive or more prevalent or happens more in these countries. These scores strongly relate to people's perceptions about living standards and personal freedoms and the presence of social networks or the ability to take care of yourself, like medical, health, police. Paraguay. Paraguay had the highest, so these are the fill in the blanks, had the highest positive experience index of an 84, with a margin of error of 3.5 at 95% confidence. The population estimate, margin of error, and confidence level are determined from the sample size. So the big idea here is think about this. Did they ask everyone in Paraguay? The answer is no. They just took a sample. And just like we take from the candy machine, if you take lots and lots of samples, you're going to make some mistakes. So this is saying you can go plus or minus 3.5. But because we do so many samples, we have this confidence level of 95%, which is pretty good.
All right, so I want to talk about this candy machine because the candy machine is like a big visual for us. So let's go back to this candy machine. And in the candy machine analogy of Reese's Pieces, which one represented the population? All of the candy in the machine, the candy coming out, or the kind of histogram bar graph at the bottom? Well, the machine here represents the, let's call this distribution of the population. Distribution of the population. I'm going to put population in all caps because basically this represents all the candy, right? You're like, I don't know how many pieces of candy. It's an infinite piece. All the pieces come out. Okay, which one represents a sample of our candy? Is it the graph below, or is it the candy coming out? Well, the candy coming out, that is our sample. So I'm going to call this the distribution of the, I'm going to put in all caps, sample. That's our sample, right? I'm not getting all of the candy at once, just like put 1/4 and turn it. And then therefore, the last one below, this here, represents the distribution of the sample proportion. I'm gonna put that in all caps. And that's kind of like what we did in the warm-up there. Just strictly with numbers, right? Took 3 numbers, got some data, and then we got those 4 possibilities, and we just found that data. Well, that's like kind of like this graph here in green.
Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.